Poisson random variable, section 4.4. Poisson random variable, it's spelled like poison, but it's actually pronounced Poisson. And it represents the number of occurrences of a rare event. There's a shortcut formula for the Poisson random variable with mean mu, standard deviation, square root of mu, probability x equal little x, mu to the x times e to the minus mu over x factorial. Special number e is 2.71882818284591. It's actually a number like pi that can't be written exactly as a decimal or a fraction. The digits keep on going and there's no repeating pattern. But it's approximately 2.718. That's a pretty close approximation. And you can use a calculator for these problems, and the calculator actually has E, as a standard scientific calculator actually has E in it, so you don't need to memorize that. Okay, so the mean is 3 deaths, that's mu. The variance, sigma squared, would be also 3. The mean is, for the Poisson, the mean is the same as the variance. Standard deviation is the square root of the variance, square root of 3, approximately 1.732. So that's enough information to compute the probability of getting exactly 7 deaths. So it's going to be just plugging into the numbers. 3 to the 7, mu is 3, x is 7, e to the minus mu is e to the minus 3 over 7 factorial. And you can put that into a calculator. So it's going to be 3 exponent 7 times, and then do the e key is over the ln key, so second ln, and then we want the minus sign is different from the subtraction sign. We want a negative 3, and close the parentheses, and divided by 7, and we want 7 factorial, so we do PRB and the right arrow twice to get the factorial symbol, equals, and then equals. And I get 0.02 something. So that's significantly low. It's probability of 7 deaths is not likely if the plant is not causing the cancer. So a lot of times with these kinds of problems, these types of situations, if you have an unusual number of deaths, well, the question arises: is there something in the plant that's causing these deaths? And so then you compute a probability. What if the plant is not causing the deaths? What would the likelihood of this be of getting that many deaths? And the answer in this case is not very likely. So that leads us to think, well, maybe the plant is causing the deaths. Okay, we could also ask the probability of at least 7 deaths. That would be the probability of 7 or 8 or 9 or 10 or 11 or 12 or 13 or 14. That would be a lot of computation. Any way you do it, there's going to be a lot of computation. But there's a shortcut would be to compute the probabilities for 0 to 6, and then subtract the answer from 1. So I already did 2 through 6. We just have to do 1 and 0 here. So this is going to be 3 to the 1. Some of this you could do in your head. 3 to the 1 is 3, but you can do the calculator if you want. Let's just do this. I already did 1 on the calculator. So this is 3 to the 1 is just 3. Any number, and this is 3 times e to the minus 3. 1 factorial is 1. So this is just going to be 3 times e to the minus 3. So it's going to be 3 times, and then e is over the ln key, so do second ln, and then we want a negative 3, so not the subtract symbol, the minus sign, minus 3, and you don't really need to close the parentheses here, because if you push equals, it automatically closes parentheses, and I get 0.14 something here, 0.149 361205, and then any number to the 0 power is 1. 0 factorial is 1. So this last one is just e to the minus 3. And this is going to be, so let's clear that out. Do second ln and -3 equals 0.04 something. 0.04978 7068. Okay. So then, so the probability of at least 7, that would be 7 or more, is 1 minus the probability x is less than 7, and it's 1 minus the probability x equals 6, minus the probability x equals 5, etc. So we subtract off these numbers that we just computed, and we get approximately 0.03. So the chance that at least 7 deaths would have occurred if the tire plant was not causing the deaths would be 3%, which is significantly low. So if 7 or more deaths had occurred, there would be some cause for concern that the plant might be causing the cancer. And that concludes this presentation.